All right, everybody, we are going to be talking about graphing quadratics today in this video, and we should be familiar with the word quadratic. Quadratic is a name that we learned when we were learning about polynomials, and quadratic associates with the term x to the second power. I know we often think quad goes with the number 4, like a quadrilateral or something like that, but quartic is actually what we use for fourth power. Quadratics are second power. Long story explanation, we talked about it in another class before. Now, if it's a quadratic equation, that means the biggest power our equation will have is 2. We could have terms with x to the first power in it. We don't have to. And we could have terms with technically x to the 0 power in it. And again, we don't have to. We also describe it by saying we could have some constants in front of our variables or over here at the end. And those constants have a special name. And we just spoke about that in our warm-up. And that word was coefficients. So A, B, and C represent coefficients. They are just real numbers. They actually could be decimals. They could be fractions. They could be positive. They could be negative. It doesn't matter. X over here, this variable, that's the word we use for the X over here. It can vary. We could plug in different values for it. This variable has to be the same variable across the board. And then our exponents, we said, have to be whole numbers. And we said whole numbers are full amounts, not decimal amounts, not fraction amounts. And they are not negative, but they could be 0. Non-negative is 0 and positive, not just positive. We also talked about how technically x to the 0 does not need to get written. And you guys told me that x to the 0 is equal to a 1. We also said if it's an equation as opposed to an expression, an equation, it has to have an equal sign. And if we're going to be graphing it in 2 dimensions, or if we're going to be graphing it on what we say is the XY plane, or the rectangular coordinate system is another name that we use to describe the XY plane, or Cartesian coordinate system, right? Named after Rene Descartes. Looks like it's Descartes. This plane here, you would need 2 variables. You need one for the horizontal axis, which is actually called the independent variable. This is an important concept when we start doing word problems. To figure out which letter or variable component goes on the horizontal axis, you need to analyze a word problem and think which of these things is the independent variable. An independent variable will keep on going no matter what. It's got its own thing. It doesn't rely on something else. Whereas y, if y is not an independent variable, we could just simply say that y is the dependent variable. Y is the dependent. It depends on the x. So I often use the example if I ask, how tall were you? Well, you probably can't really answer that accurately. You might follow up with another question. You might say, how tall was I when? In first grade, yesterday, this morning, 10 years ago? What do you mean? So your height depends on your age. So your age might go on the x-axis and then your height might go on the y-axis, okay? So when we graph quadratics, the x is your independent variable, horizontal. Y is your dependent variable, vertical. Let's go over that spelling because horizontal, people usually spell horizontal correctly. Vertical, let's not be that person that spells it incorrectly all day, every day. I watch people spell it as verticle, C-L-E. So think Verticalifornia. So on the map, California is very tall and long like this. So think Verticalifornia. So you spell it correctly, okay? If we talk about quadrants, just so we're clear on that, quadrant 1, quadrant 2, quadrant 3, and quadrant 4, so that we all say the correct thing. And one other thing I'm going to add into this picture is I'm going to do parentheses for ordered pairs, parentheses for ordered pairs. And I'm going to describe with plus and minus signs if they're positive or negative in each place. So your first part of an ordered pair is the x, and then x moves it either to the right or to the left. And then the second part is y, and that moves it up or down from wherever you left off. We originate at the origin, hence the name origin. And if I go this way, that means my ordered pair was positive, positive. If I go left and then up, that means I have an ordered pair that is negative, positive. If I go left down, negative, negative. And if I go right down, positive, negative. Okay. Now, the graph of a quadratic, the quadratic is describing the equation. The equation has the name quadratic. The graph that goes with it has a different name. That's a 1, not an arrow. The equation that goes with it has a different name. And the, not equation, what am I saying? Graph. And that graph is called a parabola. People say this a little funny. I feel like it's an awkward thing to pronounce sometimes, but we'll get there. All right. The graph is called a parabola. Now, parabolas aren't restricted to either being, we talked about these two shapes already, either being a U that looks like a smiley face or a U that looks like a frowny face. We could actually have parabolas that are totally sideways, opening up to the right, opening up to the left, and we could actually tilt them where they're on an angle. However, in Algebra 2, we focus on something called a function, and a function will only have one output or dependent variable answer for every input or independent. So if I ask you how tall were you and you tell me, oh, 5'2" and 6'3". No, you weren't those two heights yesterday. You know, you were one height. Sure, I guess you could have said you grew however much in one day. Okay, yeah, but in any one instant, you have one height. You should only have one answer for that. And the words I just used to describe that, I'm adding on to my vocab here. Input goes with independent, goes with X. Output was the word I used over here for the Y, output. I'll try to highlight all this in a minute so we could fix that. But the graph is called a parabola. Parabola, we name this point over here. It is either the highest or lowest point in this picture, depending on how we look at it, right? If we have a parabola opening upward, it has a lowest point. The name of the lowest point is called a minimum. So when we say, what is the minimum of that graph, the minimum value or the maximum value, that is asking you about the y coordinate. So it's like, what, you know, when we get old, we shrink, okay? So maybe you ask, you know, Grandpa, what's the tallest you ever were? And Grandpa's like, I used to be 7 feet tall. Okay, Grandpa. So maybe Grandpa used to be 7 feet tall. That was his maximum height. Did he tell you when he was 7 feet tall? No, he just said my maximum height was 7 feet tall. So usually if we ask for a maximum or minimum value, I only need the y value, the output of it. And if I ask you, at what point does the maximum occur? Point. Think of the point as being the tip of a pen or a pencil. On a graph, when I plot that down, a point is a coordinate point. You need to tell me x comma y in parentheses. So if I ask you at what point, the word point in the question, I want a coordinate point. You can't say like, at that point in my life, I really knew I wanted to major in, you know, zoology. Okay. Point in math means x, y coordinate. All right. This one over here, we would call it a maximum. As we get further into things, we are going to use phrases like local maximum, or another word for it is relative. And another phrase is called absolute maximum or absolute minimum. And all that means is, you know, maybe someone in our class is the local or relatively the tallest person in the class. All right. So maybe someone in the class is relative maximum height. So I don't know how tall you guys are because we're doing remote learning. So we can pretend. So, we can say that Manuel is the tallest person in the class. How tall are you, Manuel? Are you there? Is he going to respond right now? Somebody want to give me their height if you're kind of tall? You could type it in the chat if you want. You don't have to answer out loud. Or if you're pretty short, if you think maybe you're the shortest in the class. You want to tell me how tall you are, anybody?
Well, I'm 5'2".
All right, so we could say Tahani's 5'2". Maybe, oh, Tahani is the shortest person in the class. She is like relatively the shortest person. If I say she's relative shortest or local shortest, does that mean she's absolutely the shortest person in the world? Shortest person that exists? No, right? Yeah. So if you are an absolute minimum on a graph, that means on that graph, every point, and this is another thing I think people don't always understand, because when you guys draw a point on a graph, I feel like we draw a heavy, dark mark. But everywhere that you draw, even a line, and you just take your pen or pencil and draw, that represents dots, points like this. But we don't draw like that. We're going to be plotting all day. You know those artists that draw, if you get really close to the painting, it's just like all those dots, pointillism kind of thing, and you get really close. Well, if I did that, sure, I could make my graph that way, but why wouldn't I just draw it and connect it, So we just draw it smooth, and the word we use is continuous. Another vocab for us. Continuous means that you can draw it without picking up your pen or pencil. So something like a polynomial, which we graphed already in the previous unit, is continuous. Whereas if I drew something like, so that's an example of continuous. And if I drew something like here, and then my graph stopped, and then I started up again, and I drew something like that over there, well, that is not continuous. I definitely could not draw that without picking up my pen or pencil. So we can say this has got a discontinuity, or it's discontinuous. Just giving you the vocab, okay? Am I spelling this right? No, what am I doing? Discontinuous. There we go. All right. Maximum, minimum. Local or relative means in that area, if you kind of just focus on that area in the class or at that part of the graph, that's the highest point. Like here, this point on this discontinuous graph is what we call a local maximum. Locally, in its little vicinity, it's the highest. But is it the highest point on the entire graph? No way. Here, this goes up forever. Here, this goes up forever. We're going to have points that are higher. So that is not the absolute maximum. Here, though, not only is it a local minimum, but it's actually an absolute minimum. This graph, there's no point lower than it. It is the lowest point on the graph. This is a local minimum, not absolute. Local minimum, maybe a local minimum there, okay? So just so we have some vocab to kind of throw around, all right? Now, this form of a quadratic, we're going to talk about two forms right now. We have what you probably have seen more often back in Algebra 1. We have standard form of a quadratic. Standard form of a quadratic. And that is y equals 𝑎𝑥²+𝑏𝑥+𝑐. But we also have vertex form. And they both have their pros and cons. They both have something good about it, something less good about it. They're both fine though, and you're able to go back and forth between the two of them. So vertex form and standard form, I guess I don't need those colons there, but they are going to both have x squared in them. This one will look like x minus h squared plus k, and I really should have put an a out in front right there, okay? So make sure you get that down. This one is standard form, and this one is vertex form. Standard form, we have no parentheses. All the like terms are combined. It's in descending exponential order. And vertex form, it's not quite factored. Factored form looks a little bit different. It's not quite factored, but it is going to have this one little portion that is sort of gonna be factored, but we will have plus or minus possibly a number on the side of it, so it's not quite factored form. I'm just gonna put down here, actually I guess I'll keep it about halfway through. Factored form as well. And I'm just gonna kind of write like my own little generic way to represent factored form of a quadratic, and that's gonna be y equals, now I'm gonna throw random letters out here. Let's do, I'll use M, N, P, and Q, okay? We could have mx plus n, px plus q. It might look something like that. Everywhere I have plus signs could be minus signs, right? We usually default to plus. Here, this minus is special because we usually don't default to a minus sign in an equation, and we're going to talk about why we use a minus sign there. And factored form should look familiar. M, N, P, Q. They could even be like a 1 out front. It's still factored, all right? Now, let's do one example, all 3 ways, so we could kind of compare and contrast. As an example of standard form, we could have something like y equals, let's say we had, okay, I just want to make sure I pick a nice one. X to the second power plus 2x minus 3. Here we have an example in standard form. We also spoke about, we should be kind of comfortable with it, finding the x value of the vertex when we have standard form. What was that little formula? You could type it in the chat. You could say it out loud if you'd like, but if you just want to type it, the x value of the vertex, it's only 50% of the vertex. It is not all of it. What is that little formula? We use A, B, C, something over here with them. So do you want to tell me what is that going to be? Go ahead, Adriana, you want to say?
Negative b over 2a.
Negative b over 2a. Good. So let's try and figure out what is the x value of the vertex in this example. So this is a formula that we use when we have something in this form, and that's what we have. So we don't need to worry about what this value is. That's C. I need to worry about A and B, fill them in, and figure out my x value of my vertex. So did anybody get what the x value of the vertex would be? Anyone get that? You could just type that number into the chat if you write that out in your notebook. Take your time.
What was the question?
If this is the formula to figuring out the x value of the vertex, and this is the example we're looking at, that's where A, B, and C could be found. Here's our little formula. What is the x value of the vertex of this equation right over here? So this is the quadratic equation, and we're analyzing the parabola that we're going to try to draw from, that we're going to try to graph from here. So it's negative b, you got to figure out what b is, over 2a, you got to figure out what that is. Then the second part after that, if you wanted to get a head start, after you figure out x, before we started recording, you guys told me to get the y value that goes with it to make the point, we would take that answer for x and plug it in. So I do see a few people typing in the chat that you guys got -1. So let's try it out. So if I did x equals negative b over 2a, good habit, write out the formula till you memorize it. Negative means opposite. Opposite of 2, -2 over 2 times whatever the a value is. What's the a value in this example? What's the a value over here? A is the, if you look up, it's the thing in front. 61?
What?
Did you say 61?
No, I said, would it just be 1?
Oh, yes,
Or would
1.
it
I
be
thought you
1?
said 61. I was like, I don't know why you're
No.
getting 61. Yes, it's just the 1. Thank you. So whenever there's no number there, a lot of people like to try to put the X with it. The X doesn't go with it, okay? It's just the number in front. And if nothing's written, it's usually a 1 or a -1. If there's nothing here, it might be a 0. Like when we talked about placeholders when we did division. Then we just show our work. -2 over 2 times 1 is 2. And -2 over 2 is -1. So all of you who typed -1 as your X value of your vertex, you were right. Now, if we want to get the Y value of the vertex, we're going to take that X value and we're going to plug it in for X. So I'm going to plug it in right there and right there. So I'm going to get now Y equals, I don't have to write the 1, but if you remember a couple classes ago, Paige said she plugged in a negative number somewhere and she used her calculator and she was getting a different answer. And we said that you have to be careful and use parentheses, okay? Because it does the order of operations and it'll square the number and then multiply by negative. It makes a big mess. You can't always rely on that calculator because if you don't type it in correctly, the calculator can't tell you, I don't think you meant to do this. And it's just going to do what you ask it to do. What's -1 squared? You guys type it in the chat, shout it out. -1 squared. And look how I wrote it in parentheses. That's the trickiest part of this whole part of this step. What do we get if we do -1 squared? What does that equal? Type it in the chat. Is that +1 or is it -1? Think about what squared means and think about how I have parentheses around -1. I have the squared on the outside. Good. Jabari says it's 1. I concur. Here, +2 times -1 makes it -2 -3. Does anybody remember something I told you last class that was a trick to knowing if you were doing the right thing with these two terms that I just underlined that would happen when you were combining like terms and you were finding the Y value of the vertex? Take a second and think about it. I'm just going to label a vertex over here. But does anybody remember I said, if you're doing the vertex correctly, blah, 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 this will always happen just for when you're finding the vertex. Adriana, you think you remember?
It will equal the n number.
It won't equal the end number. The first two terms will equal something though. Paige, do you remember?
It would be the opposite of the first.
Yeah.
It's like the opposite of the leading coefficient.
Yeah, not the coefficient, but like when you're doing the calculation, you'll get this. You'll get 3 numbers. 1, 2, 3. The first one is 1. And then if you are doing your work correctly and you combine the first 2 terms that are here, you will get the opposite of the first term. So 1 minus 2 is -1. So I know I'm doing pretty good. Okay. So that's -1 minus 3. And what's -1? You're in a hole 1 foot deep, -3, and you dig 3 feet deeper. How deep in the hole are we now? What is the answer? Go ahead, Justin.
-4.
Nice, -4. So that's the Y value. So the vertex, I'll just label it with a V, is at -1, -4. What quadrant is that point in? What quadrant is -1, -4 going to be in? Which quadrant is that? You want to finish that, Justin, since you just told me -4?
Would it be quadrant 3?
Yes, quadrant 3. Good. All right, that's the bottom left corner. Could anyone tell me by looking at my example, is this parabola, we said the graph is going to be a parabola, is this parabola opening upward or downward? Is this parabola opening upward or is it opening downward? Is it going to look like a smiley face or is it going to look like a frowny face? You want to tell me? Go ahead, Isa. Yeah.
Because it's positive.
Yeah, it's going to open upward. It's going to look like a smiley face. You might remember from in polynomials when we did end behavior, it's positive and even, up, up. So it looks like that shape right there. Okay, so all good stuff. This is another thing we haven't talked about in a little bit when we graphed polynomials. Does anybody remember what the last number in your polynomial equation could help you find? Or what it does help you find? Does anybody remember what -3 is? Natalie, you remember?
Is it the y-intercept?
Yeah, it's the y-intercept. Good. So the y-intercept would be 0, -3. Ooh, -3, sorry. And that could help us draw our graph. Especially if your graph, we showed that picture before, it's symmetrical, meaning it's straight down the middle, it matches on both sides. So if you have the vertex, then you know the middle. X equals -1, okay? X equals -1 is also known as your axis of symmetry. That's the line where you would fold something in half. And if you can plot a point on the side at 0, -3, then all you have to do is figure out what would be the point on the opposite side. So we're just going to wrap up this example today, and we're going to continue with those next time. I'm going to start sketching this out and show you guys what it looks like. -1, -4 was where my vertex is. So I'm going to go over here to my graph. I'm going to draw as neatly as I can a graph. If you art teacher hack that I remember my high school art teachers teaching, we all tend to draw lines better in one direction holding our pen or pencil. So maybe like kind of holding it this way. So instead of, you would pull your hand down in one direction, your lines get a little wonky. So if you draw a line one way and you make your own graph paper, just rotate your paper 90 degrees and then draw whatever lines you need the other way so they make nice right angles. What did we say? Two lines that make a right angle. What did we say the word is to describe them? Go ahead. Who is it? I hear somebody unmuted. Ariel, do you know the word?
Oh, it's perpendicular.
Yes, good. So I'm just going to go here. I'm going to go out about 6 in each direction. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, actually, another thing I like to do too, these are like little graphing hacks in life, is I'm probably going to mess this up now, but whenever I want to make sure all my tick marks are evenly spaced, if I would normally pick 8 to be my number, and I would go out a certain distance and I would cut that in half and put another point, cut that in half, both of them in half, and then cut all of those in half. That gives me 8 points, and they usually end up all being pretty evenly spaced if I do it that way. So I go out pretty far, and then, that same distance all the way around, and then I put a tick mark in the middle of each, in the middle of all those, in the middle of all those, and you get 8 tick marks, okay? So we said, I already forgot, -1, -4. So again, this is the x-axis. Here is -1 on the x-axis. I just said that is what we also can call our axis of symmetry. So we'll make sure we write that down too. So we were to say the equations, lines have equations, points have ordered pairs. Equation x equals -1. It doesn't have y in it, but it is an equation because it is a vertical line. It's literally every point where x equals -1 will go along here. We draw it dashed because it's not really on the graph. It's just there as like a guide, So if you ever trace something out or whatever and you use something as a guide, it's not necessarily part of the final product. It was just there to help you draw. If you use a ruler to help you draw a straight line, the ruler comes away and you take it away and then you're left with your drawing on the paper. That is called the axis of symmetry. Then on the axis of symmetry, we go down 1, 2, 3, 4 on that axis of symmetry. And right here, I'm going to draw a nice point. I'm going to draw an arrow, label it as an ordered pair now, coordinate point, -1, -4. And that is the coordinate point, or just point, or coordinate point of the vertex. And it's either the highest or lowest point. Isa, I believe, told us it's opening upward. So the coordinate point is going to be the minimum point. what would be the minimum value for this graph? We just said it's opening upward. And I told you about what we want when we say minimum value. So what would I write down as my minimum value for this graph? I'm not done drawing it, of course, but does anyone know what we would put for the minimum value? Anybody remember? I said the minimum value, we always just give the blank coordinate. So I don't need both x and y. Do I want the x or do I want the y? If I'm looking for the minimum. Go ahead, Kennedy, which one?
Is it the y?
Yeah, it is the y, the highest or lowest. We would look at it vertically, so we just want the y. So the minimum value is -4. Okay, now we said the y-intercept was 0, -3. Be careful with those ordered pairs that have a 0 in them because people plot them on the wrong axis all the time. But Natalie told us the y-intercept is 0, -3. Since I'm not fully sketching this yet, I'm just kind of getting it started. We said this is an axis of symmetry. Can somebody tell me what other point can I plot on my picture to help me make a better, fuller graph? If it's symmetrical over the dashed line, and I have my vertex here, I have my y-intercept here, what other point can I plot that has to also be on my graph? Ella, you gonna try?
Could you just do the positive version of it?
Positive version of what?
Of like the two points. So it's like at the -4, so it'd just be a +4.
Well, it's not symmetrical over the y-axis. It's symmetrical over this dashed line. So if I fold it there.
So then on the
So here to get to this one, I had to go right one and up one. I'm going to go back here. Where could I go to plot another point if it's symmetrical?
oh, down and left.
Close. We're going to go left. And anybody want to tell me where to go from here to make a symmetrical point to that one? Symmetrical over this line. If I fold it in half, pretend this is wet paint, and I fold it in half on the dotted line, where will I get a blob of paint on my paper?
Oh, left and up.
Yeah. We're going to go left and up right there. And that will be our symmetrical point. And the ordered pair for that point would actually be, this is -2. So it'll be -2, -3. And let's just call it our mirror point. So it's like a mirror image. We'll just nickname it. That's not really, you know, what anyone calls it. But we'll just call it that for right now. So it's going to be the flipped point of that one there. And like I said, I'm not going to go all the way because we're going to talk about next class how to get the the x-intercepts and all that. So I'm just going to kind of leave this unfinished. I'm going to leave this unfinished. But that is just to get us started on how to get your graph of a parabola from the standard form of a parabola's graph, which is a quadratic equation. Okay, so this is all still from the example on the previous page. And what we're going to do is we're going to compare this same graph in different forms, vertex form and factored form. And we're going to talk about how to change your equation from one to the other. I'm pretty sure people could get factored form all by themselves. Vertex form, maybe we'll have a few people that could figure out a cheap trick to do that. But hopefully we kind of jotted this important information down. I'm going to color coordinate that for us later on. And I will end this video here. And then if you watch this video later and you use it to study, if you are like, yeah, I pretty much understand this, I think I'm clear, I don't have questions, click thumbs up. And if you don't understand and you're like, I definitely have questions, I'm overwhelmed, this is scary, put a thumbs down, and I'll inventory the ups and downs, and that helps guide how we do our next class. Okay? So have a very nice weekend. I will probably just post 1 or 2 things for homework just to try. I'll ask you questions about finding these types of things. So I hope you copied them down and you'll have this video there as well. All right. So have a great weekend. Bye guys.
Fun. Thank you.
Bye.